What's up, guys? My name is Donnie, and today we enter the brotherly concept of permutation, which is combination. As I mentioned before, combination is when the order of the sets does not matter. The main concepts we'll study today are definition and usage of combination and its features. The definition and usage of combination. Here in the diagram, we see 6 candidates are going out to the elections. If 3 are to be chosen, what will be the total number of possible events at this situation? Now, some of you might say, oh, that's simple. You just do 6 times 5 times 4, 6 times 5 times 4, because you lose a space as we should gain more candidate. No, that does not happen. This permutation works only if the order matters. Let's assume that we have chosen A, E, and F as our candidate. Does AEF and EFA are they different? No, they are the same because here we do not care in what order the candidates are chosen. We care who is chosen. This is where we use combination. The equation for combination is NCR. NCR, if you change this into a mathematical equation, it becomes n factorial divided by r factorial divided by n minus r factorial. It's kind of tricky, right? Let's apply this to the equation above. We have 6 candidates and we're going to be choosing 3. So the equation will be 6C3. 6C3 would become 6 factorial over 3 factorial multiplied by 6 minus 3 factorial, which will be 6 factorial, 3 factorial, 3 factorial, which equals 6 factorial is 720, 3 factorial is 6, 3 factorial is 6, 6, 6, 36 equals 20. This is combination. Let's try another problem. We have 7 blue balls here and 3 red balls. If we were to choose 4 balls without putting the ball back, what is the probability that we choose all 4 blue balls? So now what should we do first? Let's get the total number of events choosing the blue balls first. So that will be out of 7 blue balls, we're going to choose 4 blue balls. That will be 7 factorial over 4 factorial. 7 minus 4 is 3. 3 factorial, which is 7 times 6 times 5, because from the 4, it's all divided out, cancelled out by 4 factorial here, divided by 3 times 2, which is 6. So we cancel out here. It becomes 35. So now, next, we'll have to get the total number of possible events. That will be out of 10 balls, we will be choosing 4 balls. So that will be 10 factorial over 6 factorial, 4 factorial. Same theory here. All the numbers multiplied by 6 to 1 will be cancelled out in the both numerator and the denominator. So it will be 10 times 9 times 8 times 7 over 4 times 3 times 2 times 1. Here, if we simplify, it will be like 3 cancel out, 4 and 8, 2 left over, 2 cancel out. So it will be 3 times 7 times 10 is 210. So our answer would be 35 over 210, which is, if you divide by 7, 5 over 30 equals 1 over 6. Now let's look at the features of combination. The first feature of combination is that NC0 is always 1, and we can prove this by shifting it into an equation. NC0, if we interpret this into a mathematical equation, it will be n factorial over n minus 0 is n, so it will be n factorial and 0 factorial. Now, as we've seen before, 0 factorial equals to 1. So this will be n factorial over n factorial, which will be 1 in the end. This is how we prove NC0 equals always 1. Now, second feature is that if R from NCR, this R, is bigger or equal to 0 and smaller or equal to n, then NCR is equal to NCn minus R. This is kind of complicated. So let's prove this again by changing it into an equation. So first of all, NCR, we know that it will become n factorial over R. Let me change this. R factorial and n minus R factorial. Now what would happen if we switch n? Let me change this into another color. What would happen if we interpret n, c, n minus r into a mathematical equation? It will become n factorial over what's n minus r, and then n minus r factorial. This would become n minus r would become positive, because if you cancel out this parenthesis, it will become n minus n plus r. So n will cancel out. Factorial, gotta put factorial here. So it would, in the end, this becomes n factorial over r factorial n minus r factorial, which is equal to NCR. So by this, we know that NCR equals to NCn minus r. Now, if we can use this feature the opposite way. Now, we can use this feature in the opposite way. If we know that if a problem says NCR is equal to NCP, then we know that P is either equal to R or P is n minus R, because we've just known that NCR is equal to NCn minus R. These are the features of combination. The last part of today's video. I prepared 3 questions so far for today. I want you guys to pause the video and then solve the problems yourself first, and then later catch up with my solutions. Right, now I'll start solving the problems. First question, if First question, if x First question, if this is a 7 here, if 7c4 equals 35, what is 7c3? Now we've learned in the front that if NCR, if there's NCR, this is equal to NCn minus R. And that's exactly what we have here. We have 7c4. 3, we know that it's 7 minus 4, so we have 7c7 minus 4. Therefore, we know that 7c3 is exactly same as 7c4, which is 35. Next question. What is 8c6? Now, this question tests you just to simply solve the combination into a mathematical equation. So 8c6 will be 8 factorial over 6 factorial 2 factorial. That will be 8 times 7, because all the rest from 6 factorial will be cancelled out, divided by 2, which is 7 times 4 equals 28. Last question. There are 5 people. If we are to choose 3 and align them into a line, what would be the total number of possible events? Now, this question is testing you guys whether you should use combination, when you should use combination, and when you use permutation. So first, we're going to choose 3 people out of 5. That will be combination. So out of 5 people, we are choosing 3, which equals 5 factorial, 3 factorial, 2 factorial, 5 times 4, 2 equals 10. Now we have chosen 3 people and we are going to align them into a line. That would be 10 times 9 times, actually we are going to use permutation. So out of 3 people, we're going to choose 3, we're going to align them into a line, which will be 3 factorial over, what's 3 minus 3? 0 factorial, which is going to be 3 times 2 times 1 is 6. So there are 6 different ways to align 3 people. So all we gotta do is multiply 10 and 6, 10 times 6, which equals 60. So there is total 60 possible events of choosing 3 people out of 5 and aligning them into a single line.